going to discuss about the structure of atom and the two models, that is J.J. Thomson model and the Rutherford's model. Let's get started. Thomson, J.J. Thomson and Rutherford. These two scientists laid the formation of modern structure of atom. It is now believed that the atom is made up of many particles, that is electrons, protons, neutrons, positrons, etc. These all particles are known as the subatomic particles. These are called the subatomic particles of an atom, whereas the electrons, protons and neutrons, these are the building blocks. These are the building blocks of an atom. These are called the fundamental particles of an atom. These are the fundamental particles. If we talk about every particles, collectively they are known as the subatomic. And if we only discuss about the electrons, protons and neutrons, which are also the building blocks, these are known as the fundamental particles. Now we are going to discuss about the J.J. Thomson model. Now in Thomson model, we will discuss how the charged particles are distributed. We will discuss about the distribution of charged particles in an atom. Now we see that Thomson told us that atom is a sphere of positively charged sphere, in which this is a positively charged sphere in which electrons are embedded, to make this atom whole as neutral. We see that this is positively charged atom onto which these electrons are embedded, which are negatively charged. So the whole atom is neutral. This model was also known as plum pudding model. So it was compared to as plum pudding model. Also, it seemed like it is a pudding onto which raisins are placed. So it was also known as plum pudding model. This model failed as during further investigations made by the scientists, this model was not consistent. So we came across the Rutherford model, which we are going to discuss now. Rutherford's model. His model was also known as nuclear atomic model. Nuclear atomic model. Now Rutherford explained that atom consists of heavy positively charged nucleus, that is, this is an atom, this is a heavy positively charged nucleus. This is nucleus where whole mass of atom is concentrated. That is, the whole mass of the atom is concentrated over this particular portion, which is positively charged, called the nucleus. Now size. The size of the atom is 10,000 times the size of this nucleus. Size of the atom is 10,000. That is, this whole atom is 10,000 times larger than this nucleus. Coming to the next part, which is the extranuclear part. We see that outside this nucleus there is this empty space, which is called the extranuclear part. This is known as the extranuclear part, along which the electrons revolve. These electrons revolve in particular stationary orbits with very high speeds. Next point, this model is also similar to the solar system. The nucleus representing the sun and these electrons revolving are compared to the planets revolving around the sun. Also we see that the number of electrons is always equal to the number of protons in in these atoms. Now this model was also rejected. Now we will see what were the drawbacks of the Rutherford's atomic model. We see that any particle in a circular orbit undergoes acceleration. Any particle, that is, if this electron is moving in circular orbit, it will undergo acceleration. And if it undergoes acceleration, we know that any charged particle, be it a proton, be it an electron, any charged particle undergoing acceleration loses energy. And if this electron will revolve around the nucleus, it will continuously lose energy. And a time will come that this revolving electron would fall into the nucleus, losing energy, and it will, finally a stage will come that it will fall into this nucleus. And thus the atom will become very unstable. But we know that atoms are very, very stable. So this was not explained by Rutherford, and hence his model was disregarded. Now the next model that came into our existence, which is followed now, is the Bohr's atomic model, which is discussed in higher classes. Thank you so much.